Hey everyone, and welcome back. We're living in an age where AI is transforming everything, from how we search for information to how businesses operate. Companies are investing heavily in AI, deploying sophisticated models, and scaling their infrastructure to meet demand. And if you're running AI workloads in the cloud, you're likely keeping a close eye on your cloud dashboards, specifically your GPU utilization metrics. Most of you probably see numbers like 70%, 80%, even 90% GPU utilization and think, great, we're getting our money's worth. Our expensive GPUs are working hard. But what if I told you that those high utilization numbers are often lying to you? What if they're masking a massive amount of wasted spend, inefficient operations, and a hidden drain on your profitability? This isn't about raw compute power. It's about the actual work your GPUs are doing versus the cost you're incurring. And understanding this distinction is crucial for any modern software business. Let's dive into the illusion of efficiency. Cloud providers like AWS, Azure, or GCP charge you for GPU instances by the hour. Whether your GPU is busy or idle, you're paying for that allocated time. Now, there's a fundamental difference between training AI models and running AI inference. Training often involves long, continuous computation, where high GPU utilization is genuinely desirable and achievable. But for most businesses, the bulk of their AI spend, especially for customer-facing applications, comes from inference, making predictions with a trained model. Inference workloads are typically bursty, latency-sensitive, and unpredictable, responding to real-time user requests via APIs. This is where the illusion begins. So, what is GPU utilization actually measuring? When your dashboard shows 90% utilization, it's often referring to the activity of the GPU's streaming multiprocessors, or SMs, the core compute units. It tells you how busy the arithmetic logic units are. But a GPU is a complex system, and compute is just one piece of the puzzle. The silent killer of efficiency, especially in inference, is often memory bandwidth. If your model is constantly fetching data from memory, or if the data doesn't fit into the fast-on-chip cache, your SMs might be waiting, leading to lower effective throughput even if they appear busy. Then there are data transfer overheads. Getting data to and from the GPU involves moving it across the PCIe bus from the CPU, and potentially over the network if your data source isn't local. These transfers take time and consume resources. If your inference requests are small and frequent, the overhead of moving data can dominate the actual compute time, leaving your GPU cores idle for significant portions of their build hour. Consider batching, grouping multiple inference requests together. While larger batches can increase throughput and GPU utilization by keeping the SMs fed, they also introduce latency, which might be unacceptable for real-time applications. It's a critical trade-off between cost efficiency and user experience. Furthermore, the software stack itself introduces inefficiencies. So, the true cost isn't just GPU hours * hourly rate. It's GPU hours * hourly rate / actual useful inferences performed. This cost per inference metric is what truly matters for your business's bottom line. Why does this hidden inefficiency matter so much? Because wasted cloud spend directly impacts your profitability and your ability to scale. Every dollar spent on an underutilized GPU is a dollar that could have been invested in product development, marketing, or other growth initiatives. It slows down your innovation and makes your AI services more expensive for your customers, affecting your pricing strategy and potentially increasing churn. Addressing this requires a mature approach to ML ops and performance engineering. It means moving beyond simple utilization dashboards. Start by profiling your models to understand their true bottlenecks. Is it compute, memory, or I/O? Explore model optimization techniques like quantization, which reduces the precision of model weights, making them smaller and faster without significant accuracy loss. Or pruning, which removes unnecessary connections. Model distillation can transfer knowledge from a large model to a smaller, more efficient one. Consider specialized hardware. While general-purpose GPUs are powerful, custom ASICs or purpose-built inference chips can offer significantly better performance per watt and per dollar for specific workloads. Cloud providers are also offering more specialized instances. Embrace serverless inference platforms that dynamically scale resources down to zero, so you only pay for the actual compute time your model is actively processing requests. This is a form of automation operations that directly tackles the idle time problem. Implement advanced monitoring that tracks not just GPU utilization, but also throughput, inferences per second, latency, and critically, the cost per inference. Set up alerts for deviations from your target cost efficiency. The future of AI infrastructure will rely on intelligent schedulers and dynamic resource allocation systems that can predict demand, pre-warm instances, and efficiently pack diverse workloads on a shared hardware. This is how you transform your AI infrastructure from a cost center into a true competitive advantage. So, before you celebrate those high GPU utilization numbers, remember, they might be telling you a partial truth. It's time to look deeper, understand the true mechanisms of AI cost, and build a strategy that ensures every dollar you spend on AI is delivering maximum value. Your business's future depends on it. Thanks for watching, and I'll see you in the next one.